right, so this particular unit, we are beginning our study of trig. And as I've mentioned before, we're going to call this Unit 2. That's what it has been in the past. And so I'm just going to keep it. We're going to have 2 Unit 2s. And this one is on angles and their measure. Here are some state standards. Do not worry about those. But our first task in our lesson of lesson 1 is what is an angle? What is an angle? An angle is the union of 2 rays with a common endpoint. So we have 2 rays, 1 ray, here's a ray, and they have the common endpoint. You can also say that an angle is formed by rotating a ray about its endpoint. So like if you have a ray here and you rotate it, then what's formed is an angle. Okay, so when the vertex of an angle is at the origin of a coordinate plane and its initial side coincides with the positive side of the x-axis, the angle is said to be in standard position. Okay, so we've talked in this statement, we've talked about an initial side. So with an angle, this over here where I've rotated the ray, this would be the initial side. And this would be considered the terminal side. It's kind of hard to write slanted. This is the terminal side. This is where the ray ends its rotation. So this is talking about standard position. Standard position is when you have an angle whose position or whose vertex is at the origin. So here is the initial side of a ray, or of an angle rather. Here is the vertex, and let's just say that the angle was rotated this direction and it stopped here. This angle would be said to be in standard position. Standard position because the vertex of this angle is positioned at the origin and the initial side coincides with the positive side of the x-axis. So what are we used to using to measure angles? So we're used to using degrees. We're 60 degrees, and today it's probably going to be 100 degrees outside as I'm making this video. But we're used to using degrees. There is also another unit of measure that we will actually be talking about, and that is radians. So there's degree measure and there's radian measure. Another basic characteristics of units of measure, we often use Greek letters to name angles. In geometry, you probably used A, B, C often, especially when you had a triangle. Like if you had a triangle, you might label this angle A, angle B, angle C. You might even have an angle that you've labeled X or X degrees. But oftentimes, Greek letters are often used to name angles, and you're going to see Greek letters. A couple of just familiar ones that you might be aware of is this little symbol here. That means that is a Greek letter, alpha. You might be familiar with this Greek letter, which is sigma. Let's see if another one. Here's another one you might be familiar with. Well, that's bad. It's kind of a little squiggly in the middle. This is, well, well, I've drawn a blank. Okay, let me forget. Let's skip that one for a minute. Good grief, what the heck? Anyway, there's all kinds of different angle measures, and as we go through them, and my brain will get back onto thinking in terms of Greek letters, and we'll share those. But let's get back to degrees and angles. When you have an array that makes a complete 360-degree rotation, its path is a circle. So let's just look at this. Let's say we have a little ray, and let's say we rotate it. We start rotating it, and we rotate it 360 degrees. You'll notice that the path is a circle. This angle, we rotated it in a counterclockwise rotation. And whenever you measure an angle in a rotated array in a counterclockwise rotation, your angle is going to be a positive measure. If we take an angle, you can also, well, it's not really what I wanted to do, but I will. This is going to be an angle in the coordinate plane like we did up here. If we rotate this angle in a negative direction, if we rotate it in a clockwise rotation, then the measures are going to be negative. So when you rotate an angle in a counterclockwise rotation, your angles are positive, and a clockwise rotation, your angles are going to be negative. All right, let's talk about a central angle. A central angle is an angle whose vertex is at the center of a circle. So if you have a circle, let's say we have a circle, you learned in geometry that an angle, let's say we have this is considered to be a central angle since the vertex of this angle is at the center. Okay? All right, so when we use degree measure, a degree can actually be broken down into minutes and seconds, smaller parts. So between 1 degree and 2 degrees, you can have an angle measure that is like 1.5 degrees. So you might have an angle that looks like this. Let's say we have, I'm going to start with decimal degrees. Let's say we have an angle whose angle measure here is 10.5 degrees. So it's halfway between 10 degrees and 11 degrees. Well, in DMS, I'm going to go backwards. In DMS, that same angle would be 10 degrees, 30 minutes. And so what we're going to first talk about is how do we go about converting angles that are in decimal degrees to DMS form, and how do we take DMS and convert it to decimal degrees. Okay, so you will need your calculator. So let's look at 10.5 degrees. All right, so when you want to convert or express a decimal degrees in terms of degrees, minutes, and seconds, DMS, well, you're going to keep the whole number degree part, 10 degrees, and you're going to take 0.5 and you're going to multiply it by 60. There are 60 minutes in 1 degree. So we will take 0.5 and multiply it by 60. That gives us 10 degrees plus 30 minutes and then we put that all together, and it would be 10 degrees, 30 minutes. We don't put the plus sign or the plus symbol in our final result or answer. What if we want to take 62.356 degrees and convert this degree measure to DMS? Well, you always keep your degree part, your whole number degree part, 62. Now we're going to take 0.356. We want to take 0.356 and convert it to minutes. So there are 60 minutes in a degree, so we will multiply that by 60. And that will give us plus. All right, so now I am going to use my calculator. So I'm going to take 0.356, and I will multiply that by 60. And I get 21.36. So this is 21.36 minutes. Because 21 has a decimal part, 0.36, that means I'm going to also have seconds. So I'm going to multiply the 0.36 by 60 again. Well, if I can write, sorry. I'm going to take my 60, I'm going to take 0.36 and multiply it by 60 again, because there are 60 seconds in 1 minute. So when I multiply those, 36 by 60, sorry, I'm going to get 21.6. So here we have 62 degrees plus 21 minutes plus 21.6. Oh, why did I put a degree symbol? Minutes is one little tick mark and seconds is 2. Now, if the whole idea was to take decimal degrees and convert it to DMS, we do not want decimals. So here is where we will round or truncate, either one. It'd be 62 degrees. I'm going to drop the plus sign, 21 minutes, and then I'll round that to 22 seconds. So 62.356 degrees is 62 degrees, 21 minutes, and 22 seconds. So there are 60 minutes in 1 degree. There are 60 seconds in 1 minute. All right, so now let's look at converting DMS to decimal degrees. All right, so here we have 10 degrees, 30 minutes, 15 seconds, and we want to convert this to decimal degrees. Well, very similar to before, we're going to keep our decimal portion, not decimal portion, we're going to keep the whole number portion of the degree, 10, and then I'm going to take, there's 30 minutes, so plus 30 divided by, what do you suppose, 60? Then we're going to add 15 divided by, and I'm going to let you think about that for a second. You might be inclined to think that we would take 15 and divide it by 60. Well, if you take that 15 and divide it by 60, you're going to take 15 and you'll be taking 15 and converting it to minutes. Well, you can, well, let me rephrase that. You'll be taking your 15 seconds and converting it to minutes, which then you would have to turn around and convert to degrees. But you can bypass that converting it to minutes by dividing by 3,600 instead of 60. So there are 3,600 seconds in 1 degree. Kind of like time, there are 3,600 seconds in 1 minute. So now I'm going to pull my calculator out, and I know the 10 part. The 30 divided by 60 is 0.5, so that gives me 10 degrees plus 0.5 minutes. Well, I don't need that 0.5. I don't need that minute symbol. And then 15 divided by 3,600 is 0.0041. So plus 0.004, and I'm going to round it to 2. So now we go back to when we learned how to add decimals. When you add decimals, you line up the decimal points. So your final decimal degrees would be 10.5042 degrees. And folks, please remember to put your degree symbols. The symbols and the units are very important. If you don't have your symbols on there, they don't represent angle measures. They're just a random number on a page. All right, let's do another one. So 127, let's convert 127 degrees, 18 minutes and 36 seconds. So if we take 100, we'll keep our 127, we'll divide 18 by 60, and then we will add 36 divided by 3600. So I'll go over to my calculator. I know the 127 is going to stay the same. I will take 18 and divide it by 60. I get 0.3. So I have 127 plus 0.3 plus 36 divided by 3600 is 0.01. And when I add those all together, I get 127.31 degrees. So 127 degrees, 18 minutes and 36 seconds is the same as 127.31 degrees. Okay, so here's the beauty of converting decimal degrees to DMS and DMS to decimal degrees. The calculator will do this for us in a very quick and easy way. So I'm going to pull in, let me pull this previous page back in. And I want us to actually have the calculator convert 10.5 degrees to DMS. So, looking at your calculator, above this apps button, above apps, you should see angle. Okay, if you'll press second apps, look at your choices there. Number 1, you have a degree symbol. Number 2, you have a minute symbol. I'm not really sure what number 3 is for R, but number 4, you have an arrow pointing to DMS. So I'm going back to the home screen. I'm going to clear it off. So I'm going to type in 10.5. I'll go into angle, so second apps, and I want to convert it to DMS, so I'm going to choose 4. Now I'm going to push enter and look at what we get. So we get our 10 degrees, 30 minutes, and it tells us that there are 0 seconds. All right, we can do that again with 62.356 degrees. So 62.356, second angle, choose number 4, and enter. And so the calculator gives us exactly what we found, even the 21.6, but since we want DMS and we don't want degrees, we will round. Even when we let the calculator do it, we want to round that to 22. All right, so now let's talk about how do you express a DMS measurement in terms of decimal degrees. So let me just get this back up. So, all right, so if you remember when we looked under the angle feature or the angle app, second angle, we noticed that number 1 is degrees, number 2 is minutes. Well, where's the seconds? Well, the seconds is not in this listing. I'm not sure why, but if you will look at your plus key, look at the addition key. If you look above it, you'll see that the green seconds key is right there. Again, I don't know why they did not put the seconds in there, but anyway. So how do we convert 10 degrees, 30 minutes, 15 seconds to decimal degrees? Okay, we take our 10, go to angle, get our degree symbol, which is 1. Then we can type in 30, second angle, choose number 2 for minutes. And now 15, here's where we have to do alpha plus. So there's our 10 degrees, 30 minutes, 15 seconds, and enter. And so you'll see we have 10.504, which is what we have, and I rounded it to 42. So the calculator makes things very, very, very nice. Okay? All right, so I'm going to stop here with this portion of this lesson, and then we will have a second video to wrap up or talk about radian measure.